Hello, everyone. Thank you for joining us for our launch event. I'm Uday Valamsetti. I'm the product manager at StarTree. In this session, I'm going to cover a couple of things. One is I'm going to introduce StarTree Cloud Service that we released a couple of weeks ago. And then I also will cover a few things that we are adding to StarTree Cloud Service to make it easy for our users to build real-time user-facing analytics applications. There's a lot that is packed there. I will try to demonstrate this to you as part of this session. So what is StarTree Cloud? StarTree Cloud fundamentally is Apache Pinot offered as a fully managed cloud service. The service is available in public cloud of your choice. And like every other cloud service, we are also providing you performance, uptime guarantees, SLAs, all of that good stuff will be available. Now, one thing we are doing for all of our early customers is we are going to provide a dedicated Slack channel in way of support, and we essentially become an extended part of your team. Our goal really is to make sure that you are able to focus on building transformative applications and leave the management and building of the cluster, provisioning, all of that stuff to us, right? And the cloud service is available for you to get started for free. It's a very friendly user-facing, usage-based pricing. As your use cases grow, you can grow. Otherwise, you can continue on the free service. Now, what does the cloud service look like? What does the architecture look like? So today in the cloud service, there are two applications that we are releasing. The first one is Data Manager or the Data Ingestion Service. The Data Ingestion Service, you can think of it as an ecosystem of data connectors that are able to help you bring data into the cloud service. We have streaming connectors for things like Apache Kafka. We have SQL connector. So if you have a SQL database like Snowflake or BigQuery or something like that, you point it to us, and then we are able to handle all the data ingestion from there. We also have batch data sources, Amazon S3, ADLS, Google Cloud Storage. All of these options are available. So that's one part of the data ingestion service, which is essentially making it easy for you to onboard your data. The data ingestion service also carries another part, which is the lifecycle management of your data. Where is my data coming from? Who has access to that data? What is the lifecycle? How much retention do I need? Which tenant should the data go? All of this stuff is also handled by the data ingestion service. Now, if we go to the other side, the way to access the StarTree cluster, we obviously have a secure API onto which you can build your user-facing applications. Applications like Who Viewed My Profile or the Restaurant Manager that Uber Eats built or Merchant Analytics databases, Merchant Analytics applications. All of these applications, they're built using this custom secure API that we provide, right? So you can build your custom applications using the API. We also have a query console that you can use to do ad hoc analysis. So if you once you pull your data in, you want to make sure that the data looks good, the query performance is good, and all of that. You can use the query console for ad hoc analysis. We also have a JDBC connector ecosystem, which you can use to plug in your data visualization and data exploration tools. Things like Tableau, Looker, these kinds of things can connect using the JDBC option we have, and then explore the data, create internal dashboards, provide the ability to do slice and dice. Right. So now this is how the architecture looks like. Let me switch gears a little bit and show you the actual environment. Now, before we go to the actual environment, what I want to touch on is, again, the speed and the simplicity. Those are the things that we are targeting here. And I've created two scenarios that will try to demonstrate those two aspects of the cloud service, right? So let me set up the demo here. I'm using two data sets for this demonstration. Both are GitHub data because it's available and it is interesting to look at. The first data set is the pull requests and events that are happening in real time, streamed from the GitHub servers to our internal Kafka cluster. And I will show you how you can take data from a Kafka cluster, real-time event data from the Kafka cluster, and get to insights within minutes. And that's really the key here, is how simple it is if you have an event data in a Kafka stream, how simple it is to go from that event stream all the way to querying that data, providing time series charts off of that data. That's the first part. The second part, I'm using a similar model. I have the GitHub activity data. This is historical activity worth around 3 years of data. I think it's around 1.5 billion records. And this data, instead of hooking up to Kafka, I'm hooking up to a Snowflake database. I'm pulling it into Pinot and the StarTree cluster. And then we're going to do some interesting queries on that to demonstrate the power of StarTree and what we have built and what we are working on. The cloud service that I've provisioned for this demo environment is an 8-node 64 CPU cluster, 256 gigs of RAM, and around 10 terabytes of storage capacity. Now, let me switch to the demo environment here. Now, if you can see my screen, this is how this is the console that you get when you log into the StarTree cloud service. Like I mentioned, we have two applications. The Pinot is the query console that allows you to do ad hoc analysis. And the second application is the dataset manager. Dataset manager, like I said, is essentially allowing you to pull data, onboard data into the StarTree cloud, and it is making it easy for you to maintain lifecycle and things like that. So let's get started on this. This is the first thing I want to show is how easy it is to pull in data from a Kafka cluster. Right? So I click on this button, then now I am trying to create a table inside my StarTree cloud. A data set is essentially what a table looks like inside your Pinot cluster. Right? So that's what a table is. Let's call that git pull event data. And here I can populate this table either using synthetic data, or I can use one of the connectors that are available to pull data into this table, right? So I have, for SQL, I have these two. These are the, the batch options. For this particular demo, we'll use the Kafka cluster. And again, you are also able to upload a file directly. If you have, a file in a Parquet CSV JSON format, you can directly upload the file and start analyzing it. So for this particular demo, let's use the Kafka cluster, and let's select an existing connection to a Kafka cluster that I have access to. Now, one thing to point out here is the dataset manager is really built as a self-service data onboarding tool. What that means is the admin persona, the data engineer, the infrastructure person persona can come in and set it up so that the data scientists, the data engineers can onboard the data themselves. You don't need to go talk to an admin to get the Kafka information and then pull the data. So that is why it does connection management also. So if you add connections to different Kafka clusters and your S3 buckets and your SQL data stores, those connections will be maintained by the dataset manager, and self-service users can come in and leverage those to bring in whatever data they want to. So in this case, I've selected one Kafka cluster, and all of the details are automatically populated. Now, the first thing it does is it populates the topics that are available in this Kafka cluster, right? So I select the topic of interest for me here, and I select the format in which the data is present there. So immediately, it is doing a few things here in the background, and I think those are important. I'm going to talk about those, right? So the first thing it does is it identifies the schema that is represented in the Kafka topic. And it also constructs a corresponding Pinot schema based on that input schema. And this is an important thing here, right? So what happens is you could have missing data. You could have records that are misformed. And the way this Pinot schema is created is it is inferring the schema by looking at a number of records in your topic, and it is identifying the best fit schema that would faithfully represent the data that is being articulated in this particular topic. So it is not just taking one record and trying to construct a schema, it is looking at several records and trying to come up with the best schema that is possible. And it is also doing a preview of how the data would look like once it goes into your Pinot database, right? So now There are several options, several capabilities that are available in this service that I want to talk about now. So the first thing is it allows you, it automatically infers the data types for the different, for every record. What are all the different columns that are available? What is the best fit data type for that particular column, right? And here you can pick the timestamp column that you want to use for this particular table. In this case, I pick, created date milliseconds as my timestamp column. I come here, I can see that, okay, this is millisecond data. Now, it also allows you to do data transformations. And Pinot natively supports several transformations that are all supported here. And you can add those transformations directly from this particular interface. So for example, let's say I want to add a new column where I want to treat this millisecond data into a human readable data. So I create a new column saying created date hour. I make it a dimension, and let's go and pick the exact formula for this, right? Okay, so now I'm using the toDateTime function, mapping function, for creating then populating this new column. And I'm using this particular format, hourly granularity, right? So once I apply, it's going to again validate the schema, prepare the table config, and it is going to give me a preview of the data. The idea here is you can tweak the ingestion to exactly what you want to see once the data is inside your Pinot table, right? So you can add more columns, you can tweak them. Everything looks good, then you go to the next step. And again, one other thing is all of these things are available as a REST API. So we don't expect that every time you want to onboard data, you want to come here. If you want to do this and integrate it with your CI pipelines, that is perfectly fine. A REST API will be made available to the user. So go to the next tab. And now things get a little interesting, right? So one of the things that Pinot, that is unique to Pinot, at least since the time I got introduced to Pinot, that really fascinated me about this database is the pluggability and the availability of the different indexing options. I was not used to it, to be honest. So Pinot has a range of indexes that you can leverage for different workloads based on the query type. You can pick and choose what index or indexes need to be added for each of your columns. One of the things that the data ingestion service does is statically, by looking at your columns and the data types, it gives you a selection of indexes that you can pick. You can obviously change it to whatever. If you think that there are other indexes that you should be adding, you can do that, because at this point, Dataset Manager doesn't know about your query load. And we will come back to that at a later point in this demonstration. So the first thing is here, you can pick whatever indexes you want to choose. You can also pick the tenant where this particular table will belong to. Pinot natively supports multi-tenancy. You can have logical physical isolation for each tenant, and the dataset manager naturally takes advantage of that and allows you to send every table that you onboard into different tenants based on what your SLAs are and things like that. In terms of lifecycle management, data retention is captured here. You can say, how long this data should be present in my cluster. And another thing that is also taken care of is the transferring of data from your real-time tables to offline tables. This is kind of an advanced topic. Just want to touch on that. Pinot has a notion of real-time segments and offline segments. When data comes in through a streaming data source like Apache Kafka, it lands in real-time segments, but over a time, it needs to be transferred to an offline segment. And this is all transparent to the end user. That is naturally done here by Dataset Manager. You do not have to do anything special. It will take care of doing the transformation, right? So go to the next step. Now, this is the table that is getting created inside my Pinot cluster. Everything looks good. So finish, and now the cluster is the table is created inside my Pinot cluster. So refresh this. We have git pull event data, right? So now I'm getting real-time events streamed from the GitHub database onto my analytics database that now I can query and analyze. And that's really the key message here. In a few steps, I'm not really an expert in Kafka. I'm not really an expert in being able to pull data, do the transformations, but I was able to, in a self-service manner, bring real-time data into a OLAP data store. And now I'm able to query it, issue time series queries. Interesting things can be observed by looking at that data. So now let me, what was the name of the thing? Get full events. Right. Get full event data. That was my bad. There you go. So get full event data. So what I'm doing here is I'm looking at all of the commits made to this particular repo since the last 7 days, right? Now, when we talk about user-facing analytics, one of the key things, obviously the scale, the throughput, the interactive latency, those are all key things. But one aspect of the user-facing analytics paradigm is personalization. When you are providing these analytics to individual users, you want to provide personalized view of those analytics. I don't think everyone cares about all of the commits for every repo in the world. If I am a customer, I'm looking at, hey, show me the data for my repo. That is what this query is doing. So within a few minutes, I'm able to build think of it as a simple app that shows me time series data of all of the commits going into my repo. And I can do further analysis on this. All of that stuff is available because now the data is flowing through. I do not have to worry about the data ingestion. Data is going into the Kafka cluster, coming into Pinot. It is now available for me to do the analysis. That's really the first part of the demonstration. Now let's switch gears and talk a little bit about Pinot and dig into the indexing options. We've talked about the data management service, ability to bring in your data, ability to do transformations, data lifecycle management, and data governance. One of the things that we will make available to our users is anytime data comes in, changes are made to a data set, things are added, things are removed, we can provide you an audit log of all of those changes so you can track what happened and how your data is being modified or changed over a period of time. Now let's switch gears and talk about the indexing powerhouse that is Pinot. Like I mentioned, Apache Pinot has a range of indexes that are available to the users to tweak and pick and choose based on the workload that you're using. Inverted index, JSON index. For example, if you have semi-structured data, the JSON index allows you to query nested layers of the JSON without losing the integrity of the JSON object. Geo index, for example, if you have data that has latitude and longitude information, you can do efficient searches to be able to identify and build location-based applications. StarTree index, obviously the crown jewel of the Pinot indexes, allows you to do fast aggregations in an efficient way and have the ability to tailor your SLAs based on storage or performance. Obviously, going into these indexes and the power of them is beyond this particular session. What I will try to attempt is to show the power of the different indexes, at least a couple of them, and also demonstrate how, based on a workload, different indexes can have different results. So let's switch back again to the demo environment. So this is again the same Pinot cluster. And here I have a table called GitHub events. And this table is coming from a Snowflake cluster. So the actual data is in Snowflake that we are pulling using the SQL connector. So this is 1.4 billion records. Let's look at the table here. Star, run query, 1.4 billion records, right? Now, what I wanted to demonstrate is what happens when you are running queries without any indexes. What happens you have one index, what happens if you have another index. Now, Pinot allows you to add indexes dynamically. You can add multiple indexes to a column dynamically. And that is really powerful because it allows you to modulate your cluster to address the SLAs or the workload that you're seeing. depending on spikes and things like that. Now, in the interest of time, what I've done is I've created three tables, the three copies of that same table. So the same Snowflake table, the SQL connector is pulling three copies of that. So I have one GitHub events, which does not have any indexes. I have one which is GitHub events INV IDX, which has inverted index. And I have another one, which is GitHub events StarTree IDX, which has the StarTree index. Now let's run one query. Let me pick the query here. Bear with me. And let's run this query on the table without any indexes. So essentially what I'm doing is I'm doing a predicate based filtering here. I'm doing a filtering here, and then I'm doing an aggregation, right? I'm looking for these types of events, these two types of events, and I'm saying how many pull request additions were made for these two type of events. So now when I run the query, you will see it's taking 400 milliseconds, 450 milliseconds, right? That's the amount of time it's taken. Now, what really happens when you run a query like this and when you don't have any indexes? So there are 1.4 billion records. Now, the first thing it has to do, it has to filter and identify all of the rows that match this predicate. And then that's this number. And then it has to do the aggregation on this number of entries. And that's why in this case, for example, this has taken 451 milliseconds. Now let's run that same query and let's assume magically I have created this particular index on that table. Now Pinot allows you to do that. It just takes time, it's physics. In the interest of time, I'm just switching the table, running the same query. So when I run the same query, you can see the amount of time has reduced by almost 50%. Now, Pinot puts the statistics for every query in your face right here. So when you have an inverted index on the type column, it doesn't have to look at 1.4 billion docs to find out what rows match this predicate. So that's a big time savings it's getting because the index is there. So it's directly doing the aggregation. It doesn't have to go look for the columns that actually meet the predicate. Now, let's add or let's change the index to StarTree index, right? Right. So now I'm running the same query, but I've added StarTree index to that same column. There you go. Excellent. I love it when demos work so well, right? So now that same query took around 400 milliseconds without any indexes. I added inverted index. It took, let's say 250 seconds, generously speaking. And now when I added StarTree index, it has taken 9 milliseconds. Now the difference with StarTree index is you can see it doesn't have to look at 1.4 billion records. It doesn't have to look at all of the rows that matched this, which I believe is around 100 million or 130 million, something like that. It doesn't even have to do that. StarTree index is pre-aggregating, pre-computing the aggregates for all of the columns which are indexed by StarTree. Right? So for the type column, it's basically pre-computing the aggregates and it's pre-computing the aggregates and keeping them in the segment. And StarTree index again, this is not it's too deep to go into the StarTree index and the workings of it. But the way it works, at least at a very high level, is it allows you to trade off between the amount of storage that you want to allocate for your indexes to the amount of performance that you are able to tolerate or that you demand for a particular aggregation query. In this case, what we've selected is we said that anytime you want to do an aggregate, don't scan more than 1,000 rows. So what is going on here is anytime a segment is there and there are more than 1,000 rows that match, the cardinality is more than 1,000, it is pre-computing the aggregation. So when I ran this query, it only looked at 1,398 values, which is twice the number of segments that are there. And the reason it's twice the number of segments is because it's matching this and it's matching this. So instead of taking 250 milliseconds, it's taking 9 milliseconds. Now, there are two things that I'm trying to say here is you have to pick the right index to make sure that your query performance is optimal and at the highest level. And you can do that dynamically. You don't have to worry about doing it at time or taking the system down. None of that. You can, if you can pick an index, you can tune it. All of this can be done dynamically. Given that all of these index options available, what we are trying to do is to simplify the process that a user needs to go through to pick the index. So what we are building is a performance orchestrator, performance self-tuner. Essentially, the idea is when we do bring in the data using dataset manager, we do not force any indexes. You do not have to worry about the index options for each of those columns that are coming in. We let the data come in, and based on your query load, we will observe the queries. And when we see a query being executed frequently, we will automatically identify what is the best index that is suitable for that particular query. And we will dynamically add that index to the particular columns. So when you bring in data into StarTree Cloud, you do not have to worry about the indexes. And when you start running your workload based on the query that is running, we'll automatically pick the index. We will add the index dynamically, and we'll continue to tune the index to make sure that your SLAs are met. So there's two things here. One is by adding the index, we are making the process efficient. We are trying to reduce the amount of work we are doing in order to answer your queries. And that's key with Pinot. Everything that Pinot is doing, and that's something that I learned early on when I started looking at Pinot. The fundamental premise here is I don't want to increase the efficiency with which I do the work. I want to reduce the amount of work I do in order to answer the queries. So this is one of the things that we're working on that will be available to the StarTree Cloud service, where don't have to worry about the performance. We will add the right indexes at the right time and tune them appropriately, right? So I've showed you how it is simple to grab data in. And I've also demonstrated that, hey, we can do all these neat little tricks to make your queries run very fast without you worrying about it. This cluster where I have been running all of these queries is getting hit with a decent amount of load. Now, this is one of our Grafana dashboards that is monitoring this particular cloud tenant. And if you notice, there is around 13 QPS, 13 queries per second, 13,000 queries per second load going on onto this particular tenant. And you will also notice the latency. So for example, the one with StarTree index, the 95 percentile latency, the max is around 12 milliseconds, the average is around 11 milliseconds. And the 99 percentile latency, the average is 19 milliseconds, 16 milliseconds, and the max is 19 milliseconds. Again, with just the inverted index, the latency is much higher. Now, the key thing here is when you're providing user-facing analytics, the 99 percentile, 95 percentile latency is going to be very critical because it is going to drive user engagement and user interest in that application. Now, with StarTree, with this performance optimization, we are able to make sure that dynamically we'll pick the right index to make sure that your 95 percentile, 99 percentile latencies are meeting and exceeding your SLAs. So the StarTree Cloud Service, it is available for you to get started. Like I said, you can get started for free. Please visit us and we can go from there. And that's all I had for you for this demo. Thank you very much. And I will see if there are any questions that I can answer. But thank you again for joining us.